equation, number 7. So number 7 says the amount of money you spend on t-shirts is directly proportional. Those are your key words, right? So let's just say money you spend is directly proportional to the number of shirts you buy. All right? So that's my equation. So the next sentence says, okay, it's tax-free shopping weekend, and you bought 9 t-shirts and you paid $63. So 9, you don't know K, and you paid $63, right? Right after you write your equation, the next pieces of information tell you how you can find K. So if I divide this by 9, K equals what?
7.
Okay, 7. So then, after I find my K, I'm going to rewrite my original equation and plug in K. Right? So now I have amount of money equals 7 times the number of shirts I bought. So what do I have? If I paid $112 for t-shirts, then how many t-shirts did I buy? Well, 112 is the money. I know 7 is my K. I don't know S. Right? How do I solve for S?
You have to divide.
Divide by 7. You multiply this on the bottom.
Yeah.
Right? But you're trying to solve for the S. They are multiplying here, but in order to see what that S is, you gotta get rid of that 7. So you have to divide it out. Right? So what's 112 divided by 7? So that one should be
16.
16.
I stopped after I got 112. So.
Oh no! So 16 shirts. So number 9 on the homework. Okay, so the same thing. You need to go and find your key words. Okay? So the volume of a cone varies jointly. Right? Those are my key words. So go and find what it is that they're talking about before and what they're talking about after. Right? So before this, the volume. Alright, I'll call that V. Varies jointly, which is the same as direct. It just means that you have more variables. As its height and the square of its radius. So that's R squared. Right? Alright, so let's write this equation. Tom, you should write this stuff down. I'm doing like 3 problems. So the volume equals K HR squared. That's my equation. So now the next part tells me how to find the K. A cone with a radius of 6.
Radius.
Yeah. So 6. Oh, but radius is what?
Square.
Squared. So you gotta make sure you square that. And a height of 10. Okay, so my H is 10. You don't know K, right? Equals.
377.
Volume is 377. So listen, how do we find the K?
Would you like solve for 10 and 6?
Yeah, and 6 squared.
6 squared.
What is 10 times 6 squared?
Yeah, 160.
Huh?
360.
360. This problem is actually just like the one in your notes. In order to solve for K, I need to divide by 360, right? And I think the decimal is really weird, so let's just leave it as a fraction, this K. So what I'm going to do is I'm going to rewrite this original equation and just plug in my K. So I have V equals 377 over 360 HR squared. Yeah? So then now,
You rate it to 15 inches. 15 square.
Yeah, so the radius is 15 and the height is 7. So there you go. Now the next part that they're giving you is to find whatever the variable is that they want you to look for, right, Tom?
Yeah.
All right, so you're going to plug in because you know the K. So you want to find the volume, 377 out of 360, height, 7, radius is 15, and then square. And literally that whole right side, you can just put right into the calculator.
Yeah. 1575.
Is it 1649.38? Did you put it in parentheses? It says 1649.38 cubic centimeters. Okay? Did you get it now? Yeah? Alright, so let's look at number 10. In building a brick wall, the amount of time it takes to complete the wall varies directly. There it is, my key words. Varies directly. And, oh my goodness, varies inversely. Wow, there's a lot going on here, right? So let's kind of pull out our variables, okay? So I'm building a brick wall, I don't care, irrelevant. The amount of time, okay, time varies directly, so I know it's equals K, okay? Time varies directly, so multiplies with what? Number of bricks, yeah? I'll call this one N, call this one time, T. And it varies inversely, right?
So it's X on the bottom?
Yeah, on the bottom, inversely with the number of bricklayers, B. So there it is. That's my equation. And then let's use the next pieces of information to find K. A wall containing 1,200 bricks. 1,200 bricks. Which one is that, N or B?
That'd be
N, right? Because we call the number of bricks N. We don't know K. Using 3 brick layers, well then that's 3 on the bottom, right? Takes 18 hours, well then that's time. Right? You didn't even have the homework done. Alright, so then with this, how do I solve for this K? Now you move this 3.
multiply by reciprocal.
Alright, but you know what? Okay, you want to do that? Okay. You know, you could simplify. No, you know what? We'll just do that. Multiply by the reciprocal. So 3 over 1,200. Sure. Want to do that? Okay. 3 over 1,200. Good for you guys. Multiplying by the reciprocal there. Could it just multiply by 3 and then divide it? Gotta do it in one step. No, I love it. Good job. So this and this go away. And then we have K equals what? What is this? What do you get?
1.45.
What's the fraction?
9 over 200.
So K equals 9 over 200. Is that what you got? Alright. So, I'm going to take my original equation, and I'm going to plug in my K. So, I have T equals, oh, 9 over 200 looks weird if I put it on the top of a fraction, doesn't it?
Yeah.
Would you say it was 0.45?
Yeah.
Does it end at 0.45? All right, so we'll say that. That'll just make it a little bit easier for us. T equals 0.45 n over b. Yeah? So how long would it take to build a wall of 4,500 bricks if 5 bricklayers worked on it? You're looking for the time because I said how long, right? 0.45 times the number of bricks, 4,500 bricks. How many people are working on it? 5. So put the top one in first. So 0.45 times 4,500. Hit enter. And then divide by 5. What do you get?
Four oh five.
What did you get?
405.
405 hours?
Oh,
Yeah?
I should put it in the calculator.
405 hours? Was that what it said on the answer sheet? Alright, so it's not, it's 40.5 because our K is 0.045. Alright, that's okay. Okay, so today we're going to talk about graphing rational functions. Yeah. Alright, hold on. Alright, so, so we are going to look at graphing rational functions. And the parent function is y equals 1 over x. Okay? So let's do this together. Let's take a look in our calculators. Let's take a look at this graph. So we're going to go to y equals, and we're going to put in 1 divided by x. Okay? Make sure you guys are putting this in. Let's graph it. So if I look at this, okay? Now, it looks like these two curved graphs, right, that are kind of diagonal from each other. All right, let's go to second graph, and let's look at our points here. Okay, is everyone here? So, what is the one thing that kind of stands out? What's like super noticeable here? Error, yeah. There's an error there because you can't get anything when x equals 0. That's what it's saying. When x equals 0, there is no graph. The graph cannot be there. All right? So, I'll put 0, I'll put error right here. Now, at x equals 0, if there's an error, you know, I'm going to put a little dotted line, kind of like if there was a fence. Nothing there. So now let's go to -1. When x equals -1, what is your y? Look on your table. -1. Okay, so -1, -1. So we're like right there. Okay. What about at -2? What is your y? 0.5. So at -2, negative -0.5, right? -0.5. And now how about -3? What is it?
So negative 0.3.
Okay, so -0.33. 1, 2, 3, -0.33. Oh my goodness. How come it doesn't just move faster, right? It looks like it's just crawling along really, really slowly, right? Well, let's try -4. What's that -4?
-0.25.
-0.25. Oh my goodness. 1, 2, 3, 4. So then when I go back and I look at my graph or I look at my table, -0.25, -0.2, -0.1667, look at that. It looks like it wants to get really close to the zero, but it can't, right? And look at this graph. Oh, and then look at the left side of this graph. It looks like it's getting really, really close to the zero, but it's not, right? Okay. No, even if you zoom out, it's still going to be really, really close.
So it doesn't go.
Not going to go through that.
No, like it doesn't go back like off, like down.
Well, that way it doesn't matter because you already have that error on the zero, so you know it's not going to cross through that zero. Okay? So then let's go the other way. How about when I'm at 1? +1. What's my value? What's my y value? 1. Okay. And then how about at 2?
0.5.
0.5. Okay, so let me graph that. 1, 1, 2.5. Oh no, this looks like it's going to do the same thing. How about 3?
0.25.
3, isn't it 0.33?
Yeah.
1, 2, 3, 0.33. Oh. And then 4,
0.25.
0.25. Oh my goodness, this looks like it's doing the same thing, right? And that's because it is. It wants to get really, really close. It wants to cross, but it can't. All right? All right, so down at the bottom. Well, let's talk about what a rational function is. A rational function is a
So is this equivalent to like the purple thing where it was on
I don't know. I don't know if I'm gonna let you guys use that on the test, but that is to kind of give you a graphic organizer to organize all of this information. But right now, we're copying this onto our white sheet. So a rational function is a function with a variable in the denominator. So on the bottom of your fraction, you're going to have an x or a y, right? One of those, an unknown. So a graph of a rational function, those two little curvy graphs, right? That is called a hyperbola. Some students in another class kept saying hyperbola. That's just not it. It's hyperbola. Okay?
It sounds like energy drink. Hyperbola.
I know, right? If you say a hyperbola, I guess it could be an energy drink.
Yeah.
I mean, they call another drink Monster, so what the heck is that, right?
Yeah.
All right, so an asymptote. Well, this is a new word for you guys. An asymptote is a line that the what? That the graphs do not cross. It can't cross it. Here's the thing. Rational functions, they all have two asymptotes. Okay? A vertical asymptote. Well, this is written as x equals. So then a horizontal asymptote, that's written as what? Y equals. Now, how do you remember which is which? Well, this is how you can remember, right? you can do Bucks Hoy. Remember Bucks Hoy? Amount for one? Okay, so V stands for what? Vertical line, right? Since it's talking about a vertical line, I guess in this case we can talk about it as an asymptote as well, couldn't we? So our V for Bucks, or V in the Bucks, is the vertical line of the asymptote. The U, of course, stands for the slope, which is undefined. And then that x equals. That is your equation. So that's why a vertical asymptote will be an x equals. Now, for our domain. Well, the domain, of course, goes with the x because domain is talking about the x values, right? So with your asymptotes, it's actually a lot easier. Here's what I want you to do for the domain. Put your braces. We're going to take it way back to unit 1. I'm going to put x bar. And then x is basically not equal to whatever your vertical asymptote is. Right? You're going to find the number of that vertical asymptote, and then we're just going to say it could be any number except that vertical asymptote. So then let's look at Hoy. So H stands for the horizontal line, or the horizontal asymptote, in this case. What does that 0 stand for? I guess it's O for Hoy, right? But horizontal line, 0, that's the slope, right? That O is really the 0, it's the slope. 0 slope. So then my equation is y equals. So that's how I know. Horizontal line or horizontal asymptote, I go, oh, okay, Hoy. That's why it's y equals. So now for the range, you're going to do the same thing. Curly braces, but this time y. All values of y such that y does not equal whatever your horizontal asymptote number is. Okay? All right, any questions so far? All right, so now what we're going to do is we're going to go to our blue sheets. Okay? And we're going to talk about just an overview of everything. And I realize this is a lot of information, but you guys are going to be okay. Okay, so blue sheets. So if I look right in the middle, this is one way of writing rational functions, okay? And of course, we said that the hyperbolas, right, look like that. We'll just kind of trace it so we remember. Okay. So then now, here's what we're going to do. Vertical asymptote. How do we find the vertical asymptote? And all things vertical asymptote, right? Remember, vertical asymptote, I want to think Bucks. So I have to write this as x equals. So now, how do I find it? Well, you take your denominator, okay, everything on the bottom of your fraction equal to 0, and then solve. Usually solve for x, right? Here's another big hint for you. In the calculator, in your table, this is where your error is. So remember how in our y equals 1 over x, my error was at x equals 0? That's my vertical asymptote. Okay. Unfortunately, sometimes, in order to solve this, sometimes you have to do this. What is that?
GCF.
Factor. Yep, sometimes it's GCF, sometimes it might be AM, maybe dose. You're never going to have a SOAP, okay? All right. So then, if we find the vertical asymptote, well then, it's just natural of us to talk about the domain. Vertical asymptote affects your x's. Domain is your x values, right? How do you find the domain? Well, get your vertical asymptote, right? Get VA, not Virginia, vertical asymptote. I know, I just wanted to see if you guys are still listening to me. Cindy was. Kevin was. Kevin looked at me like, are you okay? Ethan, were you listening? Good poker face. Not even a smile. Maybe it just wasn't amused. All right. So how do I write the domain? Well, I already showed you guys in the other page, right? We're going to use set filter notation. Braces, X bar, and then what? X can't be VA, my vertical asymptote. Do you agree? All right. All right, so now let's talk about the zeros. Well, and the zeros, remember, you have a bunch of other names for it. So we could also call this the x-intercept. We could call this the roots. Or we could call this the solutions. Now, how do we find this? Well, set your numerator equal to 0 and solve. So now it's not the bottom part of your fraction, but the numerator is the top part of your fraction, right? Unfortunately, sometimes this means factoring or the square root method. And how should we write this? Well, we want to write this as an x-intercept, okay? So my y number is always going to be 0, and then I just want you to put a number in here for the x, all right? So number, comma, 0, all right? Yep, but only from the top. Like if I give you a fraction, you're taking everything from the top in the numerator and you're solving that for 0. Okay? Or setting it equal to 0 and solving for x. Does that make sense? Alright, so now let's talk about the y-intercept. Now, how do you find the y-intercept? You have two options here, okay? One's easy, one's just a little bit more math. Alright? Here's what you do. 1. You can plug in a 0 for your x and then solve. You can do that every single time for any function. If you want to find the y-intercept, plug in 0 for x. But this is another way to do it, and to be honest with you, I do it this way when I'm just trying to get it done quickly. Step 2, put in your calculator. Put the whole thing in your calculator. Go to graph, trace 0, and then enter. Graph trace 0, enter. Oh my gosh, Ethan, you know what that just made me think of? Trace 0, enter, toe. Trace 0, enter the first letters. Right? Graph, toe. Trace 0, enter. That was pretty fun. You guys don't use like acronyms? I used to do that all the time in college. Help me remember stuff. Alright, so how should you write this? Write it as a y-intercept. 0, comma, and then whatever your number is. Okay? Now, alright, this is the serious part. Okay, Kevin, you ready? Alright, so horizontal asymptote. Horizontal asymptote, guys. Okay, this one. First of all, point. Right? Point. Because horizontal, so then it has to be y equals. So this is y equals. Now, when you're looking at the horizontal asymptote, what you need to do is basically you need to look at your degree. Does anyone remember what degree means?
Okay.
Yeah, but does any old power? Your what? Smallest? Biggest?
Biggest.
Good. Your highest exponent. That is your degree, okay? So we're going to look at the degrees on the top and on the bottom, all right? So if your exponent is smaller on the top and is bigger on the bottom, then your y equals 0, always. Small to big is 0, because it's not biggie smalls, it's small. Yeah, if it's small biggie, that makes no sense, that's 0.
Yeah.
Okay. So silly, right? So silly. Alright. And actually, you're never going to have a biggie small type of situation. Like, you're never going to have a big on the top and a small on the bottom, because that's pre-calc. Okay? That's not us. Alright? We will do a biggie small later on when we talk about logs. It's so exciting. I get so happy during this. It's so fun. Alright, so the next situation that we would have is going to be same over same. So say you had an x squared on the top and an x squared on the bottom. Aren't they the same? Or if you had an x on the top and an x on the bottom, aren't they the same? So then what happens is, with these, you need to divide your coefficients. The numbers that are in front of your x's, you divide them. I hope I spelled that right. Yeah, no, spelled it right. Alright, so if we can get our horizontal asymptote, well then now we can look at the range. Since the range goes with y's, right, the y values, and my horizontal asymptote is y equals, well then how do we find the range? You got to get your horizontal asymptote. And then of course, how do we write the range? Just use your set builder notation. Set of all y values such that y is not equal to the horizontal asymptote. Okay? Now, end behavior. So remember how whenever we talked about end behavior in the past, right? We always talked about, well, is the left and right arm going up, going down, or getting stuck, right? Remember, so far, it's always gone up to infinity or down to negative infinity, right? In this unit, now we're at that stuck at a number, okay? So just to make it a little bit easier, basically, guys, the end behaviors, they're always going to the horizontal asymptote. Okay? So you need to find your asymptotes. Isn't it amazing how they're all kind of related? But you can get it all just from the equation. I mean, it's amazing. Right, Abner? All right, so let's try an example. Let's go back to our white sheets, but let's keep our graphic organizers nearby so we can refer to it, okay? All right, so let's look at this one. Which asymptotes go with this graph? So these two problems look like this because you will see problems like this on the SOL. Okay? So on the next page, yep. All right, let's look at this first one. So vertical asymptote. First of all, vertical asymptote, which one is it? Bucks or Hoy?
Bucks.
Bucks. So this has to be x equals. Now, go to your blue sheets and look at the vertical asymptote. How do we find? All right, so what does it say? How do I find the vertical asymptote? On your blue sheet, what does it say to do?
0. Solve.
Okay, set what equal to 0?
Denominator.
Good. So your denominator, everything on the bottom part of your fraction, make that equal to 0, and let's solve it. So this is 3x minus 4, make it equal to 0. If I solve this, so x equals what? X equals 4/3. So on the SOL, this will be one of those problems where you have to click on this guy and then drag it over. Okay? So now, the horizontal asymptote. Okay, let's take a look. First of all, this is Hoy, so this has to be y equals, right? Now, remember I said we need to look at the x's and look at their exponents, if there are any, right? So with this one, up on top, do I have an x? Up? Yeah. That guy right there, 2x. Tilling on the bottom, do I have an x? Yeah, 3x, right? Are those two x's the same power? Yeah, because it's just a plain old x, x to the first, and on the bottom is a plain old x, which is x to the first, right? Isn't it same over same? So if I have 2x over 3x, well then if it's same over same, I said we're only going to look at the coefficients and divide them. What's 2 divided by 3? Can you simplify that anymore? No. So that's my horizontal asymptote. Y equals 2 over 3. Not bad, right? Let's try the next one. Which asymptotes go with this graph? Okay, horizontal asymptote, we said that this is Hoy. And vertical asymptote is Bucks. So it's x equals, right? Now, how do I solve my or how do I get my vertical asymptote? What do I have to make equal to 0? What's happening? How do I find my vertical asymptote?
So 0 to the denominator 0 and then solve.
Good. Make that whole denominator at the bottom part negative x plus 1, make it equal to 0, and solve. So let's do that. Let's solve this. So subtract 1, negative x equals negative 1. Do I leave it as negative x?
No.
No. Divide by negative 1. What's negative 1 divided by negative 1?
What? 1?
Yeah, it's positive 1. So there you go. X equals 1 for your vertical asymptote. You know, that buck toy thing is actually very important because you see how one of your other answer choices is y equals 1? So you got to know which one gets the x and which one gets the y. Okay? Now let's look at the horizontal asymptote. All right, so look up at the top. Up on top, do I have an x in the top part? Huh? No, there's no x. Okay, so then that's 0. And on the bottom, do I have an x? Yeah, what kind of x? Negative x, right? Or negative 1x. First of all, there was no x on the top. That's why it's a 0. What's 0 over negative 1? Huh? 0. Y equals 0. This is that small over big, right? There is no x up at the top, so it's just 0 over negative 1, which equals 0. Does that make sense? Okay. I know this is a lot of information, but if you guys use this graphic organizer and your calculators, it should be helpful. Okay, so let's try the next one. Let's try this graph. So what they did for you is they gave you the function, which is here, but they also graphed it for you. They said use the sketch and the graphic organizer to fill in the following properties. All right, so let's figure out the asymptotes first of all. Horizontal asymptote, is it x equals or y equals? Good. Y equals. And vertical asymptote, x equals, because that one is box. All right, how do I find the vertical asymptote? Dylan told us this like twice. What do I have to make equal to 0?
The denominator.
Yeah, take that denominator, which is x plus 2, make it equal to 0, and let's solve it. So x equals what?
Negative 2.
Yeah. There you go. That is your vertical asymptote. And that actually means when you go to negative 2 on your x, well, there's an asymptote there. I used to say it was like a, tell my classes this. The asymptotes are like those invisible fence things for dogs. Like you can't see it, but it's there. You can't cross it. So if you do, you're gonna get shocked.
For like dogs?
Yeah.
Oh yeah, one of my friend's neighbors used to have one.
Yeah, they put a collar on them, right? And so anyway, this is kind of like that invisible fence. You have one going up and down, which is your vertical one. Then you have one going left to right, which is your horizontal one. Okay? So now, what about my horizontal asymptote? Let's see, up on top, do I have an x? Yeah, what x? 1x, okay, 1x over, do I have an x on the bottom? Yeah, what x? 1x. Are they the same x? Yeah, so I'm just going to look at my coefficients, and what's 1 divided by 1? 1. That is my horizontal asymptote. So that means horizontally, look at this, at y equals 1. Oh my goodness, doesn't that look good? It looks like the graphs are pulling away at that 1 as well. You see? Getting stuck. All right. So what about the domain and the range? So remember for these, I said, please let's use set builder notation. Domain is which one? X's or Y's? X. So I'm going to put X bar. Then which number can it not be? 1 or -2? Which one goes with the X? Yeah. Right? If you look, this graph goes all the way from the left and it stops at -2, can't cross it. And then really it picks up again at -2 and goes out to infinity, right? So then your range is also the same thing. Braces, not X this time because it's the range. What is it? Which values? Y. Y with a bar. And Y can't equal what number? Huh? 1. Good. Okay? Alright, so what are my zeros? And you know, really, since they gave us the graph here, we can look. I mean, you can look at, or zeros, you can also find zeros by taking your numerator and making it equal to 0 and solving, right? Up at the top, I just have an x. Make it equal to 0. Do I need to solve anything? No, it's just x equals 0. Well, then that tells me that my x-intercept is just 0, 0. Plus, don't you see it right there on your graph? Oh, so good. So good. No? What's my y-intercept? Where does this graph cross through the y-axis? 0, 0, again, right there. So that was nice. I can see it right on the graph. So now, what are my end behaviors? Good. They both go towards the horizontal asymptote. Because if you look, here's that left arm. It's gonna get stuck at this horizontal asymptote. Here's the right arm. It's gonna get stuck at the horizontal asymptote, right? So with this one, the end behaviors, I always think of horizontal asymptotes, okay? So what number is it going to get stuck at? Which one's the horizontal asymptote? 1. Okay? Horizontal asymptote. Right, Ethan? Ethan, are you on your phone? What? I gotta get off your phone. Alright, so to graph rational functions, here's what you need to do. You're gonna have to graph them.
Rational functions.
You need to find the horizontal and vertical asymptotes. And then graph them in with dotted lines. And I know that this is a whole lot, so when we go to graph it, how about we just find one point on each side of the vertical asymptote, and then we just plot them. Then we'll sketch. Okay? So find your error, and you're going to put 1 point from above the error and 1 point below the error. Now, we're going to sketch in the graphs, and remember that the graphs never, do not cross the asymptote. Right? Okay. So here are some helpful hints for you when you put rational functions into your calculator, okay? You have to put your numerator and your denominator in parentheses. The thing is, if you only have one thing in your numerator, you don't have to put that in parentheses. It's just when you have more than one, okay? You have to put it in parentheses, right? And if you have a TI-83 calculator, what it does is when it draws those asymptotes, it does like this weird thing. So it'll draw, when it draws your hyperbolas, it'll also draw your asymptotes. It's not a part of your function, okay? Some odd reason the TI-83 loves to draw in the vertical asymptote. All right, so let's look at the next one. This one, you have to graph. So instead of going in the calculator and graphing it right away, let's find the asymptotes. So horizontal asymptote, is that y equals or x equals? Good. Y equals, because that is a void. So what about the vertical asymptote?
X equals.
X equals. Do you agree, Tom? Yeah? You sure? Huh? You don't seem so sure. Abner? Huh? You're positive. Good. Yes, because it's box, which is x equals, right? All right, so how do I find the vertical asymptote?
The denominator equals 0.
Good. You take your denominator, which is x minus 2, make it equal to 0, and solve. So if you solve this for x, what do you get? Good. So x equals 2. I'm going to go to 2 on my x. I'm going to draw my asymptote. 1, 2, right here. And now where my asymptote is, the invisible fence. So, shall not cross this line. Right there. All right? Now, what about my horizontal asymptote? Well, horizontal asymptote, let's see. Up at the top, do I have any x's? No x's. How about on the bottom? Do I have any x's? 1x. Well, I guess it doesn't matter. There's no x on the top. What is this going to be? 0. Because what's 0 over what? 0, right? So at y equals 0, so here, we'll now have a horizontal asymptote. Oh, and it's right on the x-axis. Interesting. So now let's look at the domain and the range. Now, domain. Well, domain is nice. Curly x or y? X. Bar. And then what? X can't be which number? Good. You just have to look at the one that has the x or the y with it, right? And then the range is y bar. Y is not equal to what?
0.
Good. Hey guys, what else can I fill in here before I even graph it? Yes, Tom.
The two bottom ones are 0.
Good. Perfect. The 2 bottom ones are my end behaviors. And why'd you say 0?
That's your vertical.
Good. Horizontal asymptote. Horizontal asymptote. So 0 and 0. Thank you, Tom. Perfect. Okay? I was thinking about Simpsons bully kid.
Oh,
Right? That kid? I always hear it in my head whenever I write ha ha. Alright, so now zeros and the y-intercept. Okay, let's go to our calculators and let's graph this. Up on top I have 4. It's just one thing, so I'm just going to put 4. Divided by, on the bottom, do I have more than one term? Yeah, so you better put that in parentheses, x minus 2. Just like this. Put this in your calculators. Let's take a look. Say graph. Perfect. Now, I'm going to go to second graph. And I'm way too far up. I'm going to go down a little here.
5.5.
Okay, you see this? You have an error at x equals 2. Okay, so I just want you to pick 1 point above and 1 point below. That's good, and then we'll sketch it. I'm going to go with 0, negative 2, and 4, 2. You guys okay with that? Alright, so 0, negative 2, right there. Then we can just sketch, right? And then 4, 2. So 1, 2, 3, 4, 1, 2. And there we go. Pretty good, right? How pretty. Do we have any zeros? Do we have any x-intercepts? Can this have an x-intercept? No, because the asymptote is right on the x-axis. How can this graph cross through the x-axis when there's an asymptote there? So this is none. Plus, up on top, what is that, 4 equal to 0? No, you can't do that. You can't solve for anything, right? So then what about the y-intercept?
V0.
0, comma, what?
0.
Oh, you could do this. Go to graph. And trace. 0. Enter. What did it tell you?
0, 2.
0, comma, negative 2. But it's also on the table here. Look, 0, comma, negative 2. Right? Questions? All right, perfect. So look at the next one, guys. I want you to find the vertical asymptote for me, please. So your vertical asymptote, you should have found this. X equals, take everything from your denominator, 2x minus 2, make it equal to 0. Should have x equals 1. Yes? Great. Perfect. Let's graph that. X equals 1, that would be here. Now, if I know x equals 1, do I know the domain or the range? Huh? Yeah. So you know what? Why not? Let's just fill that in now too. Right? These are all things that I can do even before I go and put it in the calculator. So good. So now let's talk about the horizontal asymptote, which is HOI. So this is y equals. Now look at this one. Do I have an x on the top? Yeah. It's 1x, right? And on the bottom, do I have an x? 2x on the bottom, isn't it? Are they both x's? So just divide your coefficients. What's 1 divided by 2?
Just 1 and 2. Okay, we
Yeah,
can
it's 1/2, right? So my horizontal asymptote is y equals 1/2. And that's fine. You can get a fraction. You just have to go up to like 1/2. About right there, yeah? So if I know my horizontal asymptote, then I also know my range, right? Is what? What do you mean 1/2 and 1/2?
No, never mind. I thought you were talking about the bottom part.
No, we're talking about the range. Oh, you're talking about the end behaviors? So Tom is saying that the end behaviors are 1/2. Do we agree? Down here. Huh? What are the end behaviors? Look on your blue sheet. Down at the bottom left corner. End behaviors always approach what? Horizontal asymptote. He's right. This is ha. Horizontal asymptote, which is 1/2. Okay? It's always going to be your horizontal asymptotes, okay? So now all we have left is to graph this. Perfect. Let's graph it. So I have just an x on the top, so I'm just going to put x divided by, and on the bottom, I have more than one term, so I actually need to put parentheses around them. 2x minus 2. Okay, let's graph it. All right, that's what that looks like, right? Looks like our graph for the asymptotes. So now we're going to go to our table. We're going to find that error, and just give me 1 point above and 1 point below. That looks really nice.
0, 0, and 2, 1.
0, 0, and 2, 1. Yeah, I like those. Let's do that. Zero, 0, and 2, 1. So 0, 0 right there. 2, 1 right there. All right. And listen, even if your graphs aren't perfect, I just want you to sketch it. Okay, as long as we have the general shape, I'm happy. Just make sure it doesn't cross through the asymptotes, because if it does, you will get points taken off. Isn't the whole point of rational functions so that it doesn't cross through the asymptote? Yeah. Anyway. All right. Zeros. X-intercept. Well, you can find the x-intercept or your zeros by taking whatever's in your numerator, setting it equal to 0, and then solving, right? So this one, you just have an x. We'll set it equal to 0. Do I need to solve? No, it's already done. So my zeros, well then that's 0, 0. Plus, it's in my table. Look at that, 0, 0. Then what's also my y-intercept? 0, 0. There you go. So good. All right, questions about this? Okay, let's kick it up just a little bit, all right? So, here's what we're going to do. Vertical asymptote, we know that's x equals because that's the box. Horizontal asymptote, we know that's y equals because that's the hoi. Now, vertical asymptote, you need to take everything in your denominator, set it equal to 0, and solve.
That's going to be greatest, like, GCF.
Oh my goodness, not just GCF. Vertical asymptote, I'm going to do this down here. I need a little bit more room. X squared plus x minus 12, make that equal to 0. Oh my goodness, guys, how do I solve a trinomial?
You find the greatest common factor.
Well, the greatest common factor here is 1. Which factoring method? AM, they do even. AM. So I need two numbers that multiply to give me negative 12 and adds to give me 1. What are they? 4 and negative 3. Good. And this is just a plain old x squared, so this is going to be a simple one. X plus 4 and x minus 3. Yes? All right. And we did this in the solving, those lessons. How do I solve this? I do the mini equations, right? So x plus 4 equals 0, and x minus 3 equals 0. So x equals negative 4, and x equals 3. Guys, in this case, we have two vertical asymptotes. X equals negative 4, and x equals 3. Okay? So now I'm going to go and graph my asymptotes. One at negative 4. 1, 2, 3. Here's one at 3. Okay, so two vertical asymptotes. Now for my horizontal asymptote, let me see. Up on top, what is it that I have up on top? X squared. I have a 1x squared. How about on the bottom? What's my biggest exponent on the bottom? Same thing. It's a 1x squared. Well then, are they both the same? Yeah. They're both the power of 2, right? So divide your coefficients, and what's 1 over 1? 1. All right? Now, my horizontal asymptote is at 1, then I'm going to go over here, and I have a horizontal asymptote at 1. Oh my goodness, this is so cool, right? Guys, this is like really complex stuff. Like, you should be very proud of yourselves. This is hard stuff that you're learning. It is. It's very hard. Okay, so what is the domain? Set of all x values such that x is not equal to what?
Not equal to negative 4.
Negative 4 and
3.
and x is not equal to 3. Good. So then what's the range? Set of all y values such that y is not equal to what? 1. Good. Now, what are my horizontal asymptotes? The end behaviors. What goes here? Remember, this is ha ha. What's my ha? H-A. 1. 1 and 1. So now you have to go to your calculators and plug this in. All right? And when you go to plug this in, these are my points that are nice. I'm just going to give you guys these because of the time. 1, 2, 3, 4, 5, 6. 1, 2. Negative 6, 2. Here's 1. 0, 0. Here's 2. And 4, 2. 3, 4, 1, 2. Okay? What is your y-intercept and what is your x-intercept? 0, 0. Good. Don't leave without taking homework. So your x-intercept and your y-intercept are both 0, 0. Do your homework B. You have a mini quiz next class. Bye, guys.